Students, welcome to the class. Last class we discussed about Ampere's circuital law and magnetic field due to a straight conductor wire, infinite wire, right? So today we are going to discuss about some important points on that magnetic field due to a straight conductor of infinite length carrying current, right? So first one here, important points. First one, the magnitude of magnetic field. The magnitude of magnetic field at every point on a circle. At every point on circle of radius r is the same of radius r is same. Radius r is same means the magnetic field due to the magnetic field due to current through a straight conductor straight conductor of infinite length has cylindrical symmetry. So here the first point is the magnitude of magnetic field. The magnitude of magnetic field at every point on a circle of radius. See, ಇದು ಬಂದು ನಾವು ಈ ರೀತಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ, ರೈಟ್? ಈ ಒಂದು ಪಾಯಿಂಟ್ P ಅಂದ್ರೆ ಈ ಪಾಯಿಂಟ್ P ದಿಂದ ನಾವು ಈ ಮಧ್ಯ ಅಂಪಿಯರನ್ ಲೂಪ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿದ್ದೆ, ರೈಟ್? ಅಂಪಿಯರನ್ ಲೂಪ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡೆ ಅಂದ್ರೆ ಫ್ರಮ್ ಸೆಂಟರ್ ಪಾಯಿಂಟ್ ಇಂದ ರೇಡಿಯಸ್ ಏನಿದೆ ಇದನ್ನ r ಅಂತ ಹೇಳಿದ್ದೆ, ರೈಟ್? ಸೊ at every point on a circle, ಇಲ್ಲಿ ತಗೋರಿ ಪಾಯಿಂಟ್ ಸರ್ಕಲ್ ಮೇನ್ ಪಾಯಿಂಟ್ ಇದ್ರೆ ಏನಾಗ್ತದೆ, ರೇಡಿಯಸ್ ಎಲ್ಲ ಸೇಮ್ ಇರ್ತದೆ. ಸರ್ಕಲ್ ಆಫ್ ರೇಡಿಯಸ್ ಈಸ್ ಸೇಮ್, ರೈಟ್? ಅದನ್ನ ಏನು ಹೇಳ್ತಾರೆ, ಮೀನ್ಸ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ಕರೆಂಟ್. ಸೊ ಈ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗೋದ್ರಿಂದ ನನಗೆ ಏನು ಸಿಗಲಿದೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಸಿಗಲಿದೆ, ರೈಟ್? ಸೊ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ದಿ ಕರೆಂಟ್ through a straight conductor of infinite length, cylindrical symmetry. Cylindrical symmetry. So this is the first point. Very important. What? The magnitude of magnetic field at every point on a circle of radius r is same. Second, the direction of magnetic field. The direction of magnetic field at every point on the circle is at every point on the circle is tangential to it. here like this. So this is once again a straight conductor. So this is a point P where we have to find the magnetic field. So then we are going to consider an Amperian circular loop, right? Here what happens? Whatever we are going to consider a point on this circle. So the direction of magnetic field at every point on the circle is. So if I am going to consider like this, so this is the magnetic field tangential to it. So here the tangential to it, here tangential to it, like this it is going to be here, right? Whatever, in whichever you point going to be taken, so that is tangential to it, right? Third one. Even though the wire carrying current, even though the wire carrying current, even though the wire carrying current is infinite, magnetic field infinite, magnetic current is infinite, the magnetic field at non-zero distance, at non-zero distance is finite, How do you? So even though the wire carrying current is infinite, the magnetic field at non-zero. So non-zero ಅಲ್ಲಿ distance ಏನಿರ್ತದೆ finite ಇರ್ತದೆ. Very important, right? So and another one, fourth one is, now go to the fourth point. How we are going to find the magnetic field here? By using the right hand rule. By using the what? Right hand rule. That is important. Right hand rule. Go through it. So these are the important points on that magnetic field, right? So using a infinite length of conductor carrying, right? Next. Solenoid. Here, a solenoid consists of an insulating long wire, closely around a form, closely around on the form of its length is very large compared to its diameter. Right. So here, see, of the important topic, solenoid. Here, solenoid consists of an insulating long wire closely around on the form of a helix. Right? See here. Right. So this is the form. Right. So here, see, insulating long wire. So this is insulating long wire, right? So it is closely clamped. Hinga ondukkondu enagiruttavo close ಆಗಿರ್ತಾವೆ clamp ಆಗಿರ್ತಾವೆ. So and it is looking like on the form of which type of what? Helix. So helix ಅಂದ್ರೆ ring ಇದೆ ನೋಡಿ. ಇದಕ್ಕೆ ನಾವು helix ಅಂತ ಹೇಳ್ತೀವಿ. So ಈ ಫಾರ್ಮ್ ಒಳಗೆ ಇರುತ್ತೆ. ನಾವು ಇದಕ್ಕೆ ಅಂತ ಫಾರ್ಮ್ ಅಂತ ಹೇಳ್ತೀವಿ, helix ಫಾರ್ಮ್ ಅಂತ ಹೇಳ್ತೀವಿ. And its length is, ಈಗ ನೋಡಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇದ್ರದ್ದು ಡಯಾಮೀಟರ್ ತಗೊಂಡಿದ್ದೀವಿ. ಈ ಡಯಾಮೀಟರ್ ಎದಕ್ಕಿಂತ ಹೆಚ್ಚಾಗಿದೆ. ಕಂಪೇರ್ ಇದ್ರದ್ದು ಲೆಂತ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಎದಕ್ಕಿಂತ ಹೆಚ್ಚೈತಿ? ಇಟ್ಸ್ ಡಯಾಮೀಟರ್ ಕಿಂತ ಏನೈತಿ? ಹೆಚ್ಚೈತಿ. It is having a very long length, very large length compared to its diameter. Suppose ಇದು ಒಂದು diameter, right? ಇದು ಒಂದು diameter ಅಂತ ತಗೋ. ಇದರ diameter ಎಷ್ಟು ಹೆಚ್ಚೈತೆ ಅಂದ್ರೆ length ಬಹಳ ಹೆಚ್ಚೈತಿ, diameter ಏನಿದೆ ಕಡಿಮೆ ಐತಿ, ಗೊತ್ತಿರಬೇಕು. So that's why we are going to say here its length is very large compared to its diameter. Right? So ಇದನ್ನ ನಮ್ದು ಏನು solenoid ಅಂತ ಹೇಳ್ತೀವಿ. ಏನಂತ ಹೇಳ್ತೀವಿ? solenoid ಅಂತ ಹೇಳ್ತೀವಿ. Right? So here what happens? Next one we are going to discuss. See, if so this is the magnetic field. When the current is flowing, see here, the current direction is like this. The current direction is, see here, dot in a circle. This is cross in a circle. See here, dot in a circle means that is coming outside. See, the direction is anti-clockwise. So ನಮಗೆ ಗೊತ್ತೈತೆ, ನಾವು ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ ಏನನ್ನು ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ. So here dot in a circle is outside, coming outside of the paper. So dot cross in a circle is going inside the paper, going inside the paper. See here in this case what happens, dot in a circle means the thumb is going to show like this, right? So then what happens, the direction, the remaining fingers curl. So the curl is showing the direction, the curl is showing the direction. Which direction? Current flowing direction, right? So then see here like this, like this. So then can I write like this? Can I write like this? So here this one becomes like this, right? So next one second, sorry. Right. So this is dot in a circle. The current direction is like this, anti-clockwise, anti-clockwise, right? So then here this is like this, right? So this is once again, if I am going to do like this here, this one, this one, right? So after that one, see here, dot, 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 right? So once again, same, this is also same. So this is like this, right? So once again, this is like this, this is like this, right? So this is like this, this is like this. The direction of current, the direction of current, like this. Now see, here cross in a circle means, cross in a circle means inside the paper, inside this blackboard, the whiteboard, right? So then if this is the direction of the magnetic field like this, so then the curls are going like this, the curls are going like this. So the curls are going like this means, see here the direction is clockwise direction. Which direction? Clockwise. See, clockwise means, can I write, so this is the direction, this is the direction, now this is the direction, right? So once again here, so see, this is the direction, right? Right. See, this is the direction like this. So then here direction is like this, here direction is like this. So once again, see here the direction is like this, 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 right? Cross in a circle, cross in a circle like this, like this, like this. This is very important. This is very important, right? So see here, and another thing, in this magnetic fields, see, this one is in this direction, this one is in this direction. So here, this is cancel each other. This is what? Cancel each other. So here also, this is cancel each other. Here also, this is cancel each other. So the remaining only this magnetic field, only this magnetic field. This magnetic field is very small. So negligible magnetic field. So then outside this solenoid, the magnetic field is zero. Outside this solenoid, what happens? The magnetic field is what? Zero. Very important. ಈ ಹೊರಗಿದ್ದ ಏನು ಪ್ಲೇಸ್ ಒಳಗೆ ಏನಾಗ್ತೈತೆ ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ zero ಆಗ್ತೈತೆ. Here also the equivalent opposite magnetic fields, the equivalent opposite magnetic fields, the equivalent opposite magnetic fields becomes what? Zero. Then the here also what? The magnetic field outside this solenoid what? 0. So then now we are going to find out only inside the magnetic field. Inside the magnetic field. Right? So now I am going to consider this inside the magnetic field. Right? Like this. See. Here. Right. See, we know already here the magnetic field outside is 0. The magnetic field outside is 0. Right. So when the magnetic field outside is 0, the direction of magnetic field is in this direction. The magnetic field is in this direction. Right. Now I am going to consider here, let n number of turns are there. How many turns? Let n number of turns per unit length of the solenoid. Per unit length of the solenoid. Per unit length of solenoid. Unit length of the solenoid. Right. And I be the current and I be the current flowing through it. Now consider rectangular amperian loop. Right? ಈಗ ನಾವು ಏನು ಮಾಡ್ತೀವಿ? So n number of turns ಅದಾವೆ. ಅವು n number of turns ಏನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ? Per unit length. So ನಾವು ಒಂದು length ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಯಾವ ರೀತಿ ಅಂದ್ರೆ ಈ ರೀತಿ. So magnetic field ಈ ಡೈರೆಕ್ಷನ್ ದಾಗ ಐತಿ. Right? Magnetic field ಈ ಡೈರೆಕ್ಷನ್ ದಾಗ ಐತಿ ಅಂತಂದ್ರೆ so P Q R S. Right? ಇದು ಲೆಂತ್ PQ ಅಂದ್ರೆ S ಅಂದ್ರೆ ರೆಕ್ಟಾಂಗ್ಯುಲರ್. Right? L ಅಂತ ನಾನು ಏನು ಮಾಡ್ತೀನಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊತೀನಿ. So ಇದು ಥ್ರೂ ಏನೈತಿ I be the current flowing through it ಐತಿ. Now consider rectangular amperian loop, that is P Q R S. P Q R S near the what? Middle of solenoid. Near the middle of solenoid. Near the middle of solenoid. Right? PQ. So solenoid PQ is PQ center consider. Right? So after this one the total number of turns in length. Note the total number of turns. Total number of turns. Total number of turns of length. Right? L ಅನ್ನೋದು length ಐತಿ. ಎಷ್ಟು total number of ತಗೊಂಡಿದ್ವಿ? n number of. So ಏನಾಗ್ತೈತೆ? Total n ಅಂತ ಏನಾಗ್ತೈತೆ? Total number of turns in length. In length. Right? Then the line integral of magnetic field. The line integral of magnetic field. The line integral of magnetic field. B over the closed path. B over the closed path. PQRS. Right. Very important here. Now ಒಂದು Amperian loop consider ಮಾಡ್ಕೊಂಡಿನಿ. That is PQRS, rectangular Amperian loop PQRS. Right? It is having length L. Right. The direction of magnetic field is in this direction. The direction of magnetic field is in this direction. See, if we are going to apply the right hand rule, again right hand thumb rule. See, this shows the magnetic field. It shows the dot in circle coming outside. So when going inside, means crossing a circle. Right. After this one, here the length and the magnetic field. The length and magnetic field is in same direction. Is in what? Same direction. Here the theta becomes how much degree? 0 degree. The theta becomes how much degree? 0 degree. Now here Q to R. So Q to R. So see, the magnetic field is in this direction, length is in this direction. So the angle becomes here how much degree? Theta is equal to how much degree? 90 degree. Right. Now see, R to S I am going to take. R to S. If R to S means the magnetic field is in this direction, R to S it is in this direction. So the theta becomes what? Theta is equal to 180 degree. Theta is equal to 180 degree. And already here the magnetic field is what? 0. Already here the magnetic field is what? 0. Once again coming to S to P. This is in this direction. This is in this direction. So both the angle becomes what? 90 degree. The angle becomes what? 90 degree. Right. So now I am going to take the complete Amperian rectangular loop. So then what happens here? So a closed loop PQRS B dot dl. So I am going to take now first one Amperian loop, right? So P to Q B dot dl plus Q to R B dot dl plus. So ಎಲ್ಲಾನು ಕೂಡಿಸಿದಾಗ ನನ್ನ ಟೋಟಲ್ ಸಿಕ್ಕಿದೆ PQRS ಸಿಕ್ಕಿದೆ. So once again Q to R to S closed loop B dot dl. Once again closed loop R to S to P B dot dl. Right. So now after that one I once again I'm going to write PQRS B dot dl. Now I am going to open this dot product. So here what happens? P to Q B dl. So one day just take 0 andre cos 0 degree plus next ಇದನ್ನು ಓಪನ್ ಮಾಡ್ತೀವಿ ಯಾವುದು Q to P B dl cos 90 degree theta is equal to 90 degree plus once again B ನ ಏನೈತಿ ನಂದು 0 ಐತಿ B ನ 0 ಐತಿ ಅಂದ್ರೆ dl ಅದು 130 ಬಿಟ್ bari andre bariತೀನಿ. So once again it is what r to s 0 dl cos 180 degree 0 dl cos 180 degree ಬರೋದು ಅಷ್ಟೇ ಬಿಟ್ಟರು ಅಷ್ಟೇ. So once again plus what s to p closed integral. So then b dot dl not dot cos 90 degree cos 90 degree, right? So then once again integral p q r s b dot dl so cos 0 is equal to what? I am going to take outside this one, so then it becomes pq dl only. Cos 0 is equal to 1 plus this becomes 0, this becomes 0, this becomes also 0, right? So then here after this one pq rs b dot dl is equal to what? It becomes b into l. So ಎಲ್ಲ ಸ್ಮಾಲ್ l ಸೇರಿ ನನಗೆ ಏನು ಸಿಗ್ತೈತಿ? ಕ್ಯಾಪಿಟಲ್ L ಸಿಗ್ತೈತಿ. ಕ್ಯಾಪಿಟಲ್ L ಸಿಗ್ತೈತಿ, ರೈಟ್? ಸೊ ಕ್ಯಾಪಿಟಲ್ L ಸಿಗ್ತಿದ್ದ ನಾ ಏನು ತಗೋತೀವಿ? ದ ಕರೆಂಟ್ ಥ್ರೂ ದ ರೆಕ್ಟ್ಯಾಂಗಲ್, ಟೋಟಲ್ ಕರೆಂಟ್ ಥ್ರೂ ದಿ ರೆಕ್ಟ್ಯಾಂಗಲ್, ರೈಟ್? ಏನಾಗುತ್ತೆ ನೋಡ್ರಿ, ಟೋಟಲ್ ಕರೆಂಟ್ ಥ್ರೂ ದಿ rectangle, total current through the rectangle. So summation of I is equal to n L into current, n L into what? Current, n L into what? Current. So once again summation of I is equal to n L I. So n L ಅಂದ್ರೆ ಗೊತ್ತೈತೆ ನಮಗೆ, n L ಅಂದ್ರೆ the total number of turns in length L. So total number of turns ಎಷ್ಟಾದವರಿ length L ಒಳಗ ಅದಕ್ಕೆ ನಾನು ಏನು ಮಾಡಾಕತ್ತೀನಿ? I multiply ಮಾಡಾಕತ್ತೀನಿ, ನನಗೆ summation of current ಸಿಗ್ತೈತಿ. So then from Ampere's circuital law, so can I write here? See, summation of b dot dl pqrs is equal to mu naught I ಐತಿ, ನನಗೆ ಏನು ಬೇಕಾಗಿದೆ? ಟೋಟಲ್ ಕರೆಂಟ್ I ಬೇಕಾಗಿದೆ. ಸೊ summation of b dot dl ಏನು bl ಬಂದಿದೆ. ಸೊ bl is equal to mu naught summation of I ಅಂದ್ರೆ ಏನಿದೆ? n l I, right? So L na ಏನು ಮಾಡ್ತೀನಿ? ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ತೀನಿ. So B is equal to mu naught n I. B is equal to mu naught n I, right? So this is the magnetic field inside the solenoid. Or it can be also written as B is equal to mu naught capital N divided by L, capital N divided by L into current, or it is also written as like this. Why? Because here N is equal to total turns divided by total length. N is equal to total turns divided by total length. So total turn means capital N, total length means capital L. So this type also we are going to write that. So this is the magnetic field inside the solenoid.